Hello, we the T3C3 group are here to tell you about our marble machine project. The project was to create a box that will light up and interact to display a show while a marble travels through a path. We worked along with our motions and structures team to build this box. We were the ones that handled the software which controlled all electronics within the box. Our box consisted of 2 gates which would hold the marbles in place for 1 second using servo motors. We struggled to figure out the timing for the gates at first since the delay function could not be used, so we decided to use the millis function instead. The solution that we agreed upon was to set an end time, which would be the current time of the controller plus 1200 milliseconds. To open the gates again, we would check the current time of the controller against the end time in another conditional. For our system, the LCD display turned out to be very handy during the testing process. It helped us determine and test some of our requirements while the machine operated without any computer connection. In our system, the display worked with infrared sensors to detect and trigger events and could count marbles passing through our system. We needed our system to save as many pins on the Arduino to connect other components of the system. That caused our design to switch to an I2C version of the LCD screen, requiring only 2 data pins on the Uno. However, as we had to restrain from using the default port recommended by I2C guidelines, we had to troubleshoot to make changes. Implementing the I2C scanner on the Arduino allowed us to figure out and assign the correct pins for it later in the system's original code. Our LCD was implemented while keeping in mind that with further changes in the code, we will be able to make it function in a synchronized fashion. To support a pleasing kinetic effect, we decided to use an LED strip for easy assembly and control from only 3 pins of the Arduino. Our team had agreed on using different light effect functions when the ball is operating in the box and passing through the IR sensors. When the ball enters the box, a blasting effect would start operating on the LED, which would help to visualize that the ball had entered the box. This feature of having an LED strip allows us to bring more attention to the product and its operation. The teams must make sure that all the components of Box 5 can seamlessly interact with each other. In the consideration of the project's requirements, each team was required to come up with a design for the box and finalize them in the team leaders meeting. There are many designs that was considered in the early development phase, such as this one. But after many considerations, this design is what we ended up with. As you can see, we are responsible to ensure that 2 of the sensors can interact with both of the gates. Then we have an extra sensor to send a signal to the LCD screen to up its counter, as well as an LED strip that can change patterns depending on the state of the box. As the communications team, we're mainly working with motions team since they are responsible for wiring and electronic components in the project. In that note, we did a lot of trial and error testing while developing the code and at the same time providing feedback and recommendations to optimize the intended design with motions team. Our first few lessons were spent working with the other groups in our project to design our marble machine and make decisions on what components will be in the marble machine and how they would interact. Once our components were finalized, our group was able to create a flowchart which showed the basic structure for how our code would work. We then got together as a team and allocated which group member would create the code for which part of our subsystem. Any issues that our members stumbled upon were brought up in our group chat or in our practical classes. We then as a team worked together to solve said issues. When the motions team brought us some of the Arduino they had assembled during weeks 10, 11, and 12, we were able to test the parts of the code that regarded the LCD screen, the LEDs, and the LED strips. Any issues that we discovered were solved by our whole team working together within the lesson it was found. We were only able to test the code we had written on the assembled marble machine with the integrated Arduino system less than 24 hours before the box was due. At that time we tested the code, we noticed that the sensors were not aligned and parts of the structure fell off when the sensors moved. As the other teams were not present and the screen where the broken piece and the sensors were hot glued shut, we could not access the issue to help solve it. On the day of the submission, when all the teams were present, they attempted to fix the issues but were unsuccessful. The code which we tested on the Arduino before it was integrated with the box confirmed that the code we wrote for the servo's LEDs, LED strip and LCD screen and the sensors worked perfectly. However, we could not show this on the day of submission as the structures around the servos broke. The sensors were not aligned, so we couldn't change the lights and increment the LCD screen counter when the ball passed though. The LED strips themselves couldn't be used on the day due to the soldering coming off completely. Hence, the only code we were able to use on the day of submission was the LCD displaying the words, "We are box 5. In conclusion, we learned a lot about the process behind designing and developing a project, especially areas that are not discussed and which we can only be gained with actual experience within the engineering project. An important part of this is communicating between the teams that are responsible for the box and the ways that different aspects of the machine interfacing with each other.